All right, question number 5 says, suppose you want to approximate the area of the region bounded by the graph of f of x equals cosine of x between the x-axis and between 0 and pi over 2. Explain the basic possible strategy. So here it says we're going to subdivide the intervals, which will be the base of, and this is going to be rectangles when we do Riemann sums. It says the heights of the rectangles are going to be computed by taking the value of cosine of x at, and we can say each point of the subinterval, and this is saying 0 and pi over 2. So each point of the subinterval that we divided into, and then calculate the area over each subinterval and add them to get an approximate area. So this is just a definition of finding the area under the curve. Number 6, it says we want to approximate the area under the curve bounded by the graph. So it doesn't look like we're going to have to work anything out. We're just going to look at this problem and solve it. So using left Riemann sums, we're going to divide it into 6 subintervals. So if you do from 1 to 7, you subtract that, you'll get 6. And then divide by 6, and it gives you each interval is a distance of 1. So 1 here, 2, 3, 4, 5, and then 6. All right, using the left Riemann sum, so that's going to be the left endpoint, we're going to look at these heights. So we'll write something down. The first height is going to be 14, so I'm going to use a height of 14, and the base is 1. So you can write the 14 times 1, or you can just write 14 because each of them have a sublength of 1. So we have 14, and then our next height here, we'll make a rectangle. It'll be overestimating a little bit, but this is at a height of 11 times that change in width, but you can do all that at the end because each change is 1. So 14, 11, the next height is 8. So again, I'm using the between here and here, I'm using the left endpoint. Between here and here, I'm using this. So I'm going to use each one of these. This was at a height of 8. My next endpoint from here to here, making a rectangle, will be at 7. And then we will have a height of 4. And then after 4, we have this left endpoint that gives us a height of 3. And then that should be it. So that's 1, 2, 3, 4, 5, 6, because this one goes over to the end. So I just check. You got 6 values? 6. Alrighty. So I'm going to do 7 and 14, giving me 21. 21 plus 11 gives me 32. Plus 8 gives us 40. And then 47. So we get 47 for the left Riemann sum estimate. All right, 2, we want to do the right Riemann sum. So we're going to do similar, except we're going to do the right Riemann sum. So from here and here, we're going to use the right endpoint. So basically, if you want to, okay, instead of using 14, we're going to be using 11. So I'm going to go and use each one of these points because these are going to be the right endpoints. So start 14 to here. this line touches at 11, so that's going to be my right endpoint between these two. And then when I go to the next one between these two, this is going to be my point, which is 8. So I'm kind of skipping the 14, and I'll be having 11, 8, 7, 4, 3, and then the last Riemann sum from the right endpoint will be here. This is the last one, so between here and here, this is right, and that one ends at 0, so you just have a 0. So essentially, all of these numbers are the same except for you got rid of the 14 and replace it with 0. So if I just subtract 14 from here, that gives us a 33.